Let's start our discussion about finance by talking about interest. We'll start with the idea of simple interest. Simple interest is really just a flat interest rate, and I have a formula up on the screen that we can use to compute it. In this formula, I stands for interest. The P or P0 is the principal, or you can think of it as the initial amount that's either invested or borrowed. R is the annual interest rate written as a decimal, and T is time, and that time is always measured in years. So let's use this formula to solve an example. How much simple interest will $200 earn if invested at 7% for 18 months? So the initial investment, the principal, or P0, is $200. Our interest rate is 7%. We'll write that as 0.07. And T, time, is 18 months. We do have to convert that into years, and because there's 12 months in 1 year, we can just take 18 and divide it by 12, and that is 1.5 or 1.5. So T is 1.5 years. So I'll just plug those numbers in. 200 times 0.07 times 1.5, and I get $21. So $200 will earn $21 in 1.5 years. All right, let's look at a different example. This is still about simple interest, so we're going to use the same formula. But this problem says you borrowed $200 for new furniture and have to pay $2,300 back in 6 months. What simple interest rate were you charged? So first of all, let's actually figure out, well, how much interest were we charged? If we borrowed $200, it's $2,000. If we borrowed $2,000, but we paid back the loan with $2,300, that difference, $2,300 minus $2,000, gives me the interest that I paid. So I paid $300 in interest. All right, so we know how much interest we paid. That was $300. That's going to go into I in the formula. And this time we're actually trying to find R, the interest rate. The P, the principal, is the $2,000 we borrowed. That's our initial investment, or in this case, amount that we borrowed. And the time is 6 months, which would be a half a year. So I am going to plug those numbers in. 300 for I, 2,000 for P, and 0.5 for T. And now I can solve for R. To solve for R, the very first thing I would do is simplify the right-hand side. We can take the 2,000 times 0.5, and that gives us 1,000. So now we have 300 equals 1,000 R. To get R by itself, I'll divide both sides by 1,000. And I got R equals 0.3. And then finally, I'm going to move the decimal 2 places to the right. 0.3 is 30%. So we were actually charged a 30% annual interest rate. Now, there is another type of interest. Simple interest just assumes that your interest payments are the same, or the amount of interest you earn is the same every single month or year or whatever time period we're talking about. Simple interest is actually an example of linear growth, where the amount of interest goes up by the same amount every year. But in many situations, we can actually earn compound interest, and that would be an example of exponential growth. And the idea is we're actually earning interest on the interest from the past. So as our bank account grows, we can actually earn more and more interest. So I have on the screen the formula for compound interest. In this formula, the P0 is still that principal or starting balance. R is still our annual interest rate. K now represents number of compounding periods per year. And so that's usually specified in the problem. And just indicating how often are you paid interest. N is our number of years, and then the PN is the future value of the account, or the amount after N years. Now, a couple more comments about that. K, so number of compounding periods per year. So some examples that you might see is if the money is compounded monthly, then the K would equal 12. You get 12 payments a year. If it says it's compounded daily, then you would put 365 in for K. So you get 365 payments a year. Finally, if it says it's compounded annually or yearly, then we use 1 for K. So let's see how this formula works in an example. We've got $500. It's invested at 8% interest. How much will this grow to in 5 years if the interest is, and we'll compare this with simple interest, compounded annually, and then finally compounded daily. So part A actually says simple interest, so I'm going to go back to that first formula, I equals PRT. The P is the $500, R is 8% or 0.08, and T would be 5 years. So put that into my calculator, 500 times 0.08 times 5, and I got $200. Now, this is the amount of interest I've earned. The question actually says, how much money will we have? What will be in our bank account, basically? So we have just computed that we have earned $200 in interest. So the amount of money that we'll have will be the original investment, the $500, plus the interest we earned. So 500 plus 200 is $700. So we'll have $700 at the end of 5 years. Now let's compare this to compound interest. Will we earn more money, less money, the same amount? Well, let's see. We'll use our compound interest formula. The P0, the initial investment, is $500, so that goes in for P0. And then I have a 1 plus, the R is still 0.08. And in this case, because it's compounded annually, that means it's only compounded once per year. So I put in a 1 for K. So 0.08 divided by 1. And then the exponent, the NK, 5 years, so it'd be 5 times 1. I'm going to put this in my calculator. I simplified it a little bit before I typed it into my calculator. Just noticing that, for example, 5 times 1 is 5. And I got $734.66. So we actually earn a little bit more money when the interest is compounded. And again, that's because this is an example of exponential growth. Each year, we're earning a little bit more interest than the previous year. If it's compounded daily, we use the exact same formula. So same compound interest formula. The P0 is still 500. The R is still 0.08. The only thing that's going to change is if it's compounded daily, we're going to put in 365 for K. So now I've got 500 times 1 plus 0.08 divided by 365 raised to the 5 times 365 power. Now, to avoid rounding errors, I think it's a good idea to try to type as much of this into your calculator at once. And many calculators do have parenthesis buttons that you can use. So when I put this in my calculator, the only thing I did ahead of time is I did go ahead and compute 5 times 365, and I got that 1825 for my exponent. So I wrote down in the bottom of the screen in green what I put into my calculator. The keystrokes in your calculator might be a little bit different, but in mine, I just typed in the 500, parenthesis, 1 plus 0.08, divide 365, parenthesis, exponent 1825, and I got this 745.88. So notice that when the money is compounded daily, I actually earn even more interest. And that's because if the interest is paid out more frequently, then it gives us more opportunity to earn additional interest on that interest. In these examples, we solve for the future value of the account, but we could also be asked to find the interest rate. And I have an example that demonstrates how we can do that. So my next example says Teresa puts $200 in an account that earns interest compounded monthly. If she wants her money to grow to $300 in 2 years, what interest rate must she invest at? So the problem says compounded monthly, so I know I'm going to use my compound interest formula, but this time we're solving for R, the interest rate. Okay, so plugging the numbers in, the future value, the PN, is the $300. The initial amount is $200. 1 plus, we don't know R. It says compounded monthly, so K is 12. And then for the exponent, we're doing 2 years, so it'd be 2 times 12. And this is an equation that we can now solve for R. I'm going to start by just multiplying the 2 times 12 in the exponent, and I get 24. Okay, so we want to isolate the R, so the next step is divide both sides by 200. On the left-hand side, I ended up getting 1.5. So 1.5 equals 1 plus R divided by 12 to the 24. And then the next step is to get rid of that 24 exponent. The opposite of taking something to the 24th power is taking the 24th root of both sides. I use my calculator for this. On my calculator, I type in 24, and then I have this X root button, and then 1.5. I got 1.01704, did a little bit of rounding there. So that got rid of the exponent, so now I have this 1.01704 equals 1 plus R divided by 12. So to finish solving for R, I'm going to subtract the 1. And then I can multiply both sides by 12. And I got R equals 0.20448. I'm going to move the decimal over and do a little rounding. And I wrote that as 20.4%. So you would need over 20% interest rate if you want your money to grow from $200 to $300 in 2 years. All right, let's do one more example. How much should be, that should say invested. How much should be invested at 6% interest compounded quarterly if you want $1,500 after 3 years? So I see that word compounded, so I'm going to use my compound interest formula. But now we're solving for the initial investment. How much do we need to start the account with? So we're solving for the P0. The future value is the 1,500. That's my PN. Interest rate is 0.06. And this time, because it says compounded quarterly, we'll use 4 for K. There's 4 quarters in a year. And then the exponent, the NK, is 3 years times 4. So to solve this equation, I'll start by just doing 3 times 4 for the exponent is 12. And then I want to simplify down my right-hand side. So I'm going to take that thing in parentheses, the 1 plus 0.06 divided by 4, parenthesis to the 12th, and put that into my calculator. And then I jotted down what I got. To avoid rounding errors, it's a good idea to copy down lots of digits. I did 6 here. I think that's kind of a nice rule of thumb. Do at least 6, maybe 8. And that'll help you avoid some rounding errors. Okay, finally, we're solving for P0, so I'm going to divide both sides by that 1.195 number. So P0 is 1,500 divided by 1.195618. Put it in my calculator, and now I'll round to the nearest penny, and I got $1,254.58.